we will start by correcting the homework from Thursday or Friday, depending on when you have maths. Okay, so a bag of sweets is opened and the number of different coloured sweets is counted. Copy and complete the table below listing the number of sweets of each different colour. Okay, so red sweets, 1, 2. Blue sweets, 1, 2, 3. Orange sweets, 1, 2, 3, 4. Pink, go and get myself a pink now. It's purpley, but it'll do. Pink, 1, 2, 3, 4, 5. And then green, there's just the 1. Okay, so 5, 9, 10, so there's 15. I'm just going to count, there's actually 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, grand. Now, what is the total number of sweets in the bag? 15, just counted them twice. One sweet is chosen at random from the bag. Calculate the probability as a fraction that the sweet picked is red. Okay. So the probability the sweet picked is red. There are 2 red sweets out of a total of 15. That's it. Pink, 5 out of 15. And remember, you can use this button and type them into your calculator and see if they can be simplified. And I think that one can. It's a third. E, blue or pink. Okay, so there's 3 blue and 5 pink, so that makes 8 out of 15. F, not red. Okay, so if it's not red, then it means it can be any of the others. So there's 15 sweets in total, 2 are red. That means these have to make up 13. Is that right? 5 and 4 is 9 and 1 is 10, 11, 12. Yep, so if it's not red, it can be 13 sweets out of a possible 15. And G, what is the probability that black? Well, there's no black sweets. So 0 out of 15, which is just 0. Okay, so that's the first one. Second one, the following marbles are put in a bag. A marble is chosen at random. What is the write as a percentage the probability? Okay, so we go A. So we need the probability here as a percentage. So red marble. So 2 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2 out of 10 are red, and that will simplify to 1 over 5. B, a blue marble, so there's just a 1 out of 10. C, green is 3 out of 10. And D, not green. Okay, so not green is everything else. So 1, 2, 3, 4, 5, 6, 7 out of 10. Okay, and then the last one. A letter is selected at random from the word Killian. Find the probability that the letter selected is an A. Okay, so how many A's are there in the name Killian? There's just 1. And how many letters? 1, 2, 3, 4, 5, 6, 7. So there's 1 A out of 7 letters in the alphabet, in Killian's name. So I, how many I's are there? There's 2 out of 7. Vowels. So there's an I, and an A. So there's 3 vowels out of the 7 letters. And then D, consonants. So if there was 3 vowels, that means the rest have to be consonants. So C, L, L, and N, which is 4 out of 7. Okay, so will you check your answers to them, please? If you got them right, brilliant. I know a lot of people are getting them right. People are uploading them to Schoology so I can see them. So if you're getting them right, brilliant. If you did make any mistakes, please, first of all, make sure you take down the correct answer. And secondly, make sure you understand the correct answer, okay? If you don't, just take a screenshot and email it to me and say, like, don't understand this, help, type of thing. Okay? Or obviously, if Miss Stack is there, she might be able to help you too. Okay? If it's not Miss Stack, you can send it to me. Okay, so for today, we're going to move on to expected frequency. Now, expected frequency, kind of in layman's terms, is here in red. How often we expect an event to occur. So expected frequency kind of links to how often. Okay, so basically, how often do we expect an event to occur? Now, the way you do it is you get the number of trials multiplied by the probability. You actually normally do them in the other order. So what you do is you figure out what the probability is. And once you have it, you multiply it by the number of trials that are occurring. Okay, so again, make sure we're taking this down. Your heading is expected frequency. The writing in red just kind of explains what expected frequency means. And then this here is how we're actually going to calculate the expected frequency. Okay, so I'll say it again. You get the probability first. Can't see that. You get the probability first, and then you do this bit. Multiply it by the number of trials second. Okay? So let's try one. A student carries out a random survey of 50 people on car ownership in his local area. 40 people respond that they own a car. Calculate the relative frequency. Now, my first question is, why is it relative frequency and not probability? Why did they not say calculate the probability of owning a car? I hope you're answering me in your head. But the reason they said relative frequency is because this student is actually carrying out the survey. Okay, so do you remember relative frequency is based on an experiment? All right, so if somebody is actually doing the experiment, it's called relative frequency. If they're not, it's based on theory, and then it's called probability. All right. So this is the same as calculate the probability of owning a car. It's just because it's based on an experiment, they have to say relative frequency. Okay, so let's figure out the probability. How many people own a car? According to the survey, 40 people out of a total of 50 people. And if you put that into your calculator, that will give you 4/5. Okay, so the probability of owning a car, or the relative frequency of owning a car, is 4/5. Now, estimate how many of the 3,000 people in the local area own a car. Now, the number, see the number, is the number of trials. Okay, so we take the probability, remember I said we do that first, and we multiply it by the number of trials. Sorry, trying to find my calculator here. So we type in 4/5. So I'm using my fraction button and putting in 4/5 and then multiply by 3,000. So that is 2,400 people. All right, so based on the probability or the relative frequency that this student worked out, the probability of owning a car was 4/5. Given that probability, how many people, so that's the expected frequency, how many people did we expect to own a car in the local area? Based on this student survey, we would expect 2,400 people to own a car. Okay, so again, you just have to take down example 8.20 and you need to take down the answer. Okay, now this obviously isn't an example, but I'm going to do it as an example just so we can go through it again. So, a fair six-sided die is thrown 6,000 times. Now, there's your number, okay? So if I go back up to the formula, that's this bit here, the number of trials, okay? So we just highlight that. Find how many times the die would be, and we have expected here, to land, showing A, the number 1. Okay, so when you're trying to get expected frequency, what's the first thing that you must do? The first thing that you must do is to figure out the probability. Okay, so the probability of getting a 1 on a dice. How many 1s are there on a dice? There's just 1. Out of how many numbers in total? 6. So that's the probability of getting a 1 when you roll a dice. And then we multiply it by the number of trials. Okay, that's how you do expected frequency. First you figure out the probability, and then you multiply it by the number of trials. Okay, and that will figure out the answer to that would be that there's 1,000 1s. We would expect a 1 to come up 1,000 times if you were to roll a dice 6,000 times. Okay, and B here is the probability of an even number. Find how many times the die would be expected to land on an even number. Okay, so again, the first thing we do is the probability. So what is the probability of landing on an even number? So even numbers are 2, 4, 6, 8, 10, and so on. Okay, so how many even numbers are there on a dice? There are the number 2, 4, and 6. So there's 3 of them. Out of how many numbers on the dice? Is 6. So now I've figured out the probability. I need to multiply it by the number of trials. Okay, and if you type that into your calculator, you will get 3,000. Okay, so that's how you do expected frequency. You figure out the probability first, and then you multiply it by the number of trials. Okay, the trials could be rolling a dice, the trials could be people. Once you see that number, that's what you're multiplying by. So ignore the number, figure out the probability. Once you have the probability, multiply by the number of trials. Okay, so take your notes down and go back over it a few times if you need to. You can rewind and play me again. And this is your homework. Okay, so there's 3 questions there on expected frequency. As usual, it will be on Schoology, and please upload your homework. Okay, brilliant. So I will talk to you again on Wednesday.